Hello all, welcome to this video on microprocessors and microcontrollers. The topic of discussion today is the register set of 8051. A register is a group of binary cells that are capable of holding binary information that consist of a group of cascaded flip-flops. 8051 has two 8-bit registers A and B to store the operands as allowed by the instruction set. Internal temporary registers, namely TMP1 and TMP2, are not user accessible. Including A and B, 8051 has a family of special purpose registers known as special function registers or SFRs. There are in total 21 bit addressable 8-bit registers. A, B, PSW, P0, P1, P2, P3, IP, IE, TCON and SCON are all 8-bit bit addressable registers. The remaining registers, namely SP, DPH, DPL, TMOD, TH0, TL0, TH1, TL1, SBUF and PCON are all byte addressable. The registers DPH and DPL are the higher and lower bytes of a 16-bit register, DPTR, that is, data pointer, which is used for accessing external data memory. The starting 32 bytes of on-chip RAM is used as general-purpose registers. They have been allotted the address range from 0000H to 001FH. These 32 8-bit registers are divided into 4 groups of 8 registers each, called register banks. At a time, only one of these 4 groups can be accessed. The register bank to be accessed can be selected using the RS1 and RS0 bits of an internal register called the program status word. The registers TH0 and TL0 form the 16-bit counter or timer register with H indicating the upper byte and L indicating the lower byte of the 16-bit timer register T0. Similarly, TH1 and TL1 form the 16-bit count for timer T1. The 4 port latches are represented using P0, P1, P2 and P3. Any communication with these ports is established using the SFR addresses to these registers. Register SP is stack pointer register. Register PSW is a flag register which contains status information. Register IP can be programmed to control interrupt priority. Register IE can be programmed to control interrupts, that is, enable or disable the interrupts. TCON is called timer or counter control register. Some of the bits of this register are used to turn the timers on and off. This register also contains interrupt control flags for external interrupts INT0 and INT1. The register T mode is used for programming the modes of operation of timers or counters. SCON register is a serial port mode control register and is used to control the operation of serial port. The SBUF register acts as a serial data buffer for transmit and receive operation. PCON register is called the power control register. This register contains the power down bit and the idle bit, which activates the power down mode and idle mode in 80C51BH. There are 2 power saving modes of operation provided in the CHMOS version, namely the idle mode and the power down mode. In the idle mode, the oscillator continues to run and the interrupt, serial port and timer block are active, but the clock to the CPU is disabled. The CPU status is preserved. This mode can be terminated with a hardware interrupt or hardware reset signal. After this, the CPU resumes program execution from where it left off. In power down mode, the on-chip oscillator is stopped. All the functions of the controller are held, maintaining the contents of RAM. The only way to terminate this mode is hardware reset. The reset redefines all the SFRs, but the RAM contents are left unchanged. Both these modes can be entered by setting the respective bit in an internal register called PCON register using the software. PCON register also contains two general purpose flags and a double baud rate bit. The table on the right shows the SFR registers along with their addresses and contents after reset. So the first column here gives us the names of the registers. The second column shows whether they are bit addressable or not. The third column gives their SFR addresses, and the fourth column contains the content they have after a reset. The bit addressable register, that is the program status word register, has the given format. It has 8 bits starting from D0 to D7. D7 contains the carry flag. D6 contains the auxiliary carry flag. D5 contains F0, which is flag 0, that is available to the user for general purpose. D4 contains RS1 and D3 contains RS0. Both of them are used for register bank selection. The table given here gives us the 4 different combinations available. So when both RS1 and RS0 are 0, then register bank 0 is selected, whose address is of the range 00H to 07H. When RS1 is 0 and RS0 is 1, register bank 1 is selected and the address range is from 08H to 0FH. When RS1 is 1 and RS0 is 0, register bank 2 is selected and the address range is from 10H to 17H. And when both RS1 and RS0 are 1, the register bank 3 is selected, whose address range is from 18H to 1FH. The bit D2 contains the overflow flag. D1 is a user definable flag that is reserved for future purpose, and D0 contains the parity flag, which is set or cleared by hardware in each instruction cycle to indicate an odd or even number of 1 bits in the accumulator. That's all for now. Thank you. Thank you for listening.